Hello everyone, today I'm going to show how to create a WebSocket using API gateway with the demo application. The WebSocket can be used to live chat application, real-time dashboard or push notification, etc, etc. Along with the WebSocket, I'm going to use Lambda and DynamoDB services to show how to build a chat application which broadcasts message to all the WebSocket connection. Example, if you have a 2 or more live connection, how to broadcast a message to all the connection at once. End of this video, you should have a good enough understanding of WebSocket and its usage, so you can apply this knowledge to your day-to-day application. As usual, please like and subscribe if you like this content. It would be really appreciated. Furthermore, if you have any comment, clarification, please comment below. I will get back to you as needed. So let's get in. The application we're going to build is a sample chat application, as I mentioned. The application built with the WebSocket using API gateway, Lambda and DynamoDB. Lambda is used to implement the business logic and the DynamoDB is used to save all the WebSocket connection. When a client sends a message, the message will be back to broadcast to all the client who connected. Don't worry, we will see and start building this application step by step in second. That is the summary of this application we're gonna build. Now let's go head into AWS console and start building. Right, I'm in AWS console. Let's create a WebSocket API. To create a WebSocket API, head into API gateway. You can search over here and click on the create API. Then select the second option, which is a WebSocket API. Click on the build. Then give it a name as a demo. Let's give a demo as a demo chat. And then a route or route selection. This is a very important. Not like a usual REST API, WebSocket doesn't have verbs like get, post, delete. The request is routed to different action via reading a specific property of the message body. When the client sends a request to WebSocket API, so the server should know how to route. To identify the correct route, the request should have that kind of information. So default route selection is a request.body.action. In here, the request is the actual request come from the client. The body is the actual payload come from the client. When we define the route selection as a request.body.action, it checks the action property of the body. The sample request will be like this. So let's have a look at the postman. So this is the sample body. So the action I was talking about, this is the one. It is a request and this is a body, whole body, and this is the action property. So in our case, if we want to, we will see in a later. So when we want to send a message, we set as action as a send, and we can send any data along with this body. Of course, you can change the property action to something like test123, but by convention the property name is action. So let's stick to that name. Body.action. Let's click on next. Right, and this is where you can define different routes. Example, in the request, the action property is a connect. Then this route is get triggered. At the moment, we need 3 route. The first for the connect, second one for the disconnect, and the third one for which is something custom, which is send. We will create this as a send. So the connect and disconnect and the default are the standard routes, and you can't change the route value. So if I do this is we enable the route connect one, disconnect, and we don't need at the moment, we don't need a default route, and we will create a custom route as a send. So this is the route we're going to use to send a message. Let's click next. This is a place where you have to specify integration for each route. For example, for the connect, disconnect, and the send. So achieve that, we need a 3 lambda function to handle these 3 routes. So let's quickly have a check what each route is supposed to do. Starting from connect route, let's assume there are 3 users connected. Once they connected to a socket API, which create a unique connection ID. So what we need to do, we need to save this connection ID in a dynamodb table. That is what demo connect is supposed to do. If we go to the disconnect one, disconnect route does the opposite to the connect route. When the third user, in this example, if send the disconnect connection request, we have to remove that connection ID from the dynamodb table. If you go to the last one, which is a send message, this is handling the send route. Let's assume the user one called the send route with a message like action is a send, a message is hello WebSocket. In this case, demo send, this is a lambda, should fetch all the connection from a dynamodb table. That means all the connection for related to particular client. Then extract the message, which is a hello WebSocket, and broadcast that message to all the users. So that is a summary of each lambda supposed to do. Right, let's create a 3 lambda starting from connect. Click on the create function. I'm in the awslambda page. Click on the create function. Give it a name as a function name as a demo connect, and select the runtime as a Node.js. You can use your any preferred language, but if you want to follow with me, please use Node.js so that you can use the same code what I'm gonna use. For the execution role, I already have a create a role with the administrator permission. So you can simply create a role in IAM. So I will quickly show you how to create a role. Head into IAM. Then under roles, and click on the create role. Select the AWS service as a lambda. I'll give a little bit zoom in and click on the AWS service and the service use case as a lambda and click on next. Then select the administrator access. We are giving the full administrator access to this role. Click on the next. Create a role. Let's give a name, whatever name you can give it. Let's say text role, and give a description and click on the create a role. So for me, I already have a existing role, which is if I go to there. Yes, I'm continuing. This is my existing role, so which come with the administrator access. Right. So let's go to, I'm not going to create a one because I already have. So you can create a role with the administration access. So what I'm going to, go back to my function while I'm in progress in the creating the function. Use my existing role, which is SAM role, and click on create function. As you can see, we have a simple lambda function using a Node.js. As a side note related to the Node.js, I thought it could be better to mention some of the important tips while following this video, which is not related to WebSocket, but it's related to the Node.js. As you see, the default file is got created with the MJS extension. Node.js will treat .cjs, which is .cjs file as a common JS module, and the .mjs file as a ECMAScript module. So it will treat .js file as a whatever the default module system for the project that is defined in the package.json file. So default is a common JS. If you set the type property in the, if you have a package.json file and if you set the type property as a modules in the package.json file, then it's considered as a ECMAScript module. That's something keep in mind if you are working with the Node.js. The main difference between the common JS versus ECMAScript is how we reference other packages. So example, for the common JS we use require, and the ECMAScript use import keyword. Right, that is something different to topic. Yeah, let's back to the topic. At the moment, this is simple lambda function. What we're gonna do, we just dump, just console log the event, because we need what's coming in the event object later on. So we will update this code to make it save into dynamodb database later on, but so at the moment this is okay. Right, same way what we're going to do, we will create another two lambdas for disconnect and the send. Let's head into function again, click on create function, this one demo, this disconnect, and same runtime, and I'm going to use the same role, which is same role, create function, and again what I'm doing, I'm console log event object, deploy, same thing, deploy, again go back to function, click on create function demo, this one called send, let's say whatever name you can mention, demo send message, same runtime, existing role, same role, create function, we'll do the same thing again. Right, so we do have a 3 lambda function, but those are pretty much doesn't do anything other than the skeleton. What we're going to do, we will go back to our API gateway process. So we were in creating an API gateway, but we stop when we do the integration point, because we need to create a lambda before integration. So what we're going to do, we do have a connect. I'm in the integration, remember, in the very first screen. And now what we're going to do, we select the lambda for the connect. We are selecting the connect lambda. Let's say demo connect. That's a connect lambda. For the disconnect, we're going to select lambda demo disconnect. And the last one, again integrate with the lambda function, which is demo send message. Right, we set the integration point for each routes. Now click on the next, and then we need to set, okay, in which environment we gonna deploy this API gateway. You can give it as a dev and click on next. So this is where you can review the changes, that mean API gateway, the socket API you are creating. The API name is demo chat, and this is again very important, request.body.action, and these are the 3 routes, and these are the integration for each route, and this is a stage. Let's click on create and deploy. This will create a socket API as we expected. As you see, now we have 3 routes, not like a usual REST API. WebSocket has routes compared to resources in a REST API. Furthermore, you can add new routes over here and update the existing route over here. For example, if you click on connect, and you can update the integration request over here. So currently it's pointing to demo connect. Right. So what we're going to do now, we will try to finish the connect workflow. Let's go to the demo connect and update the code which save the connection ID into a dynamodb table. Let's head into our function which is demo connect. Right. In this demo connect lambda, we need to get the connection ID of the client who connected and save that ID into dynamodb table. But currently we don't have a dynamodb table. Let's get a table now. So head into dynamodb table, dynamodb database, and go to the tables and click on the create table. Let's give it a name as user, and the partition key as a connection ID. You can give it any name as a partition key, but in my case I'll give the connection ID as a partition key as a connection underscore ID. This will be save. This will represent the client who connected, and keep all the default setting as it is, and click on the create table. Right. It takes few seconds to create the table. Now let's go back to our lambda because we do have a dynamodb table. Now we go to our lambda. Right, let's start writing code to save the connection ID into dynamodb table. The connection ID can be found in a event object, but we don't know where it is. Let's try to see how does the event object look like. As we log the event object over here, it should be in the CloudWatch logs. Let's get a client who try to connect the WebSocket, then where we can see the CloudWatch logs. I'm using the Postman as a client, which is a free version, so you can use any tool as you prefer, but it is easy you to follow with me if you use Postman. To connect the client, first we need to get the endpoint URL of the WebSocket where the Postman client can connect. So we can find that URL in the WebSocket API. Let's head into our API, and if you go to the routes, and it should be in the stages. Under stages, what we can see, the WebSocket URL. This is the URL you want to use for connect. I'm copying this URL, go to Postman, and then click on the new and select the WebSocket and paste it. Right, now if I get some more spaces, you can save this request into, let's say, into new collection. Let's say demo chat. This is a new collection. It's saved into new collection. Right, so I'm getting more spaces. Right, we do have a URL which connect to our endpoint. So once we click connect, as you can see, it's connect to this endpoint. Theoretically we should see event object in CloudWatch logs. Right, I'm in a lambda connect lambda and go to monitor and click on the CloudWatch logs. Get some spaces, and here we go, we do have a logs, and if you see, this is a event object. We can see the event object, and which has headers and some multi-value headers. Seems like both are pretty much same, and but the important property is the request context. The request context has all the good stuff. It has what was a root, for example in this case a connect, and specifically this connection ID. This is the ID we are interested in. This connection ID is unique for each client who connected. So example, if the another Postman instance connect, there will be another unique connection ID. Right, Now we know where can we find the connection ID. Let's go to our demo connect lambda and update the code. As I mentioned in this lambda, we are saving the connection ID into dynamodb table. To achieve that, we need a dynamodb table. So I'm going to use a dynamodb AWS SDK. I will paste some code and go through a line by line. The very first thing what we need to do, we need to get the AWS SDK. In the first line, we get the AWS SDK, the client, specifically for DynamoDB client, and we do have DynamoDB client and the put item command. We need to this put item command to save the things into database. Then other than this one, I want to mention one thing. This is again the side note regarding the performance of the AWS Lambda. It is always better to initialize client, in this case the DynamoDB client, outside the handler function. This is a handler function, so we initialize our client outside the handler function. What's going to happen? Then it reuse this client object for subsequent request. If you are interested with further on the performance of the lambda function, please check out my one of the video in the comment below. So this gives a more insight about lambda lifecycle and the performance improvement. Right, let's back to topic. So now we do have a client object. Now we need to do, okay, get me some code again. I'll copy the whole bit. The lambda function, what's gonna learn, let's go line by line. Right, the very first thing what we need to do, we need to extract the connection ID. So as we know, looking at the CloudWatch logs, the connection ID is in the request context object. We get the connection ID and then try to save the connection ID into a database. This is how we can save the connection ID into database. So we need to create an object to hold the payload. This is how you can create the payload for the DynamoDB table. The item is the actual data which will be saved. In this case, in our case, we have only one column, which is a connection ID, and the type is string. Then the variable which hold the connection ID, the actual data which extract from the event object. Then we need to specify what the table name, and then over here table name, our table name is a user. After that, we need to create a put command object by passing the object we created, and finally the send the comment, send this command to the client we created in the very top DynamoDB client. Other than that, as you can see, we use try catch to handle the error. That is all, very simple, right? So if everything is success, we return 200 status code, otherwise we send a 500 error code. Right, our code is ready for demo connect. What we're gonna do, we're gonna deploy these changes. It's done. I'm getting a little bit zoom out, and now let's go to our postman. So this is a endpoint. Now we're gonna connect. So once we connect, we should theoretically see a one record in a DynamoDB table. Let's connect. Yeah, it's successful connect, you can see, and in little icon it says the green and the connected. So what we're gonna do, we're gonna go to DynamoDB table. Let's go to DynamoDB table. Our table name is user, and click on the Explorer table item, or you can go in the left side, you can click on the Explorer item and click on the table and give it a refresh. Yes, we got a one connection ID get saved. This is a connection ID for the Postman client. Right, so same way what we're going to do, we will quickly finish the disconnect lambda. So quickly go to the disconnect lambda. and I will fetch some code and go through. Right, this is a disconnect demo dash disconnect, and the code is pretty same compared to the connect lambda. So in this case, what we're going to use delete item command. The same kind of follow the code we need to follow. For example, we need to create a client and then grab the connection ID. We create the payload and the table name is user. And what we're going to, rather than put item command, we're going to use delete item command, and with the try catch. That's pretty simple. So what we're going to do, we're going to deploy again and go back to our Postman, and currently its status is a disconnect. What we're going to see, we give a refresh, it's still there. If I disconnect this, yeah, it's successful disconnect. If I come back, and here if we see refresh, so the connection ID is gone. We're gonna delete the connection ID from the dynamodb. Seems like connect and disconnect is work. Now the big part, which is a send message. Right, let's update our demo send message lambda. In summary, what we need to do is, when someone send a message, we need to broadcast that message to all the clients. For that, first we need to fetch all the connection ID from the dynamodb table, then iterate through those connection ID and post the message via API gateway client. So I will create two separate file to handle dynamodb and API client operations separately, so it's easy to see their duties. Right, what's gonna happen, I'm gonna create a new file and copy some this one. This is for the publishing message using API gateway management, gateway management client. So I'll come this and what gonna see, I'm gonna save this as a publisher .mjs and create another file to handle dynamodb stuff. This is called repository.mjs repo. Right, so it's pretty easy. Can deploy. So let's go through the code a little bit. In the main function, what we're gonna do, we import this repository and the publisher, which are on here, and we get the body object in the handler event object. This is the actual message exist. So what we're gonna do then in the try catch, because we have to handle errors, so we get all the users. We need to bring all the users, that means connection ID, theoretically the connection ID from the dynamodb table. If I go to the fetch users, which is in repository.mjs, what they're going to do, they use a dynamodb client as usual. So this time we are going to use a scan command. Using the scan command, what we're going to do, we put all the table name is a user, and scan all the record into this command and then execute it through dynamodb client. So this file return JSON object with this is an array. So within this array, we go through the items and we map each item and get the connection ID. This is the actual connection ID which is saved in the database. So we can log this console response, and we can see in the CloudWatch how does it look like this response. So in summary, this is basically pretty much what does this repository.mjs does. It's bringing all the connection ID from the dynamodb table, which is user. Then if I go to the index again, so once you get the user, this is an array, and it's go through each array object and get the user.s. Basically this is where that connection ID is saved. So once we dumping this response, we can see how does the data look like. Once we get the the users, and we get the message which is come from the event object, actual message. Then we publish. To publish, if we go to the publish method, which is using API gateway management API, and we are using the management client and the post to connection command. This is the two object we're gonna use. The callback URL, yeah, that is something we need. First, we need to create the client using the callback URL. So where do you find the callback URL? If we go back to our API gateway under staging, and you can see the connection URL. This is the URL you need to copy. And if we go back, and I'm saving this without this connection, so up to the staging. That's the I'm going to deploy, by the way. And the client, we're going to create the client using this callback URL, and plus what we're going to do when you ask to publish, we need to get the connection ID and the message. That is something we are sending from over here. This is the connection ID and the message. If I go to publish again, so we create the request param. This is one of the JSON object. The connection ID and the data is a keyword. Connection ID is the one that actually to whom we are sending the message. The data is actual message, any data object. You can send any data as a JSON object or as a normal string. In this case, what I'm doing the as a JSON string file. Then once we create the request param, which is passed to our post to connection command, which is come from our AWS SDK. Then once we create the command, then using our client object, which is API client, we execute this command. So this will broadcast, basically this one send the whatever the message to particular connection ID. But so because we are calling this function, the publish function, through the loop, so which will broadcast the same message to all the connected client. Right, that's pretty much the code for the demo send message. Now we will try this, we will test this send message function through the Postman. Let's get the two instances of the Postman, and we will pretending like two users. Right, I do have a two Postman instance in the left and right, and the left one considered as a user 1 and the second right one is considered as a user 2. So currently, as you can see, the send button is disabled. I'll show you in a bit. So let's connect first user. It's got connected, and let's connect the second user. Right, both users are connected, and once it connected, then you can see this send button. This is where you can send the actual message. If you remember the send route, basically we need to mention the action as a send. So if you remember the route configuration is like whole request and the body, then the action. This is the action they consider to route the different action. For example, if you send the connect, currently we are not sending connect. The connect is already sent by the Postman for us. We don't need to send the connect. So what we are sending the send action send to send the message. Right, let's send the message from the user 1. As you can see, user 1 send a message, user 1 hello, which appear in the user 2 console. That message got broadcast to even for the user 2. So if I send a message from the term user 2, you can see that message, user 2 message appear in the user 1 window. So basically, why it's happening, because both these connection are keep live with the WebSocket API. So if I do again, clearing the some message and click on again send, the user 1 message appear in the user 2 screen. So this is how the chat application work. If you're using any front-end framework, for example front-end application like React or Angular, you can pretend the same scenario as it is. So one thing is need to remember. So for example, in this message body, you need to pick the type as a JSON. If you select the text, for example, clear the message, and if I send it, still it's get error. I don't know why. It should give a error basically because they don't understand the action. Right, that's pretty much over here. The if we go to the our console, remember we were supposed to check the dynamodb response. How does it look like? If I go back, and this is one, go to monitor and click on the CloudWatch logs. Right, if you click on the last one, let's have a look the response object. So if you remember the response object, how does it look like? If I go back to demo send and the code where we log the response object is in a repository, and console.log, this is the response object. If we go back to our code, and this is the actual data, as you can see, this is the response coming from dynamodb table. So we basically in the logs, what we're going to check, response.count is greater than 0. That's mean this we are checking the count, which is 2 currently because we do 2 connection, and we check the, we go to the items, each items, this is item. So for example, this is item, and each object you can see the connection ID. So we get the connection ID, but connection ID is a object. So what we need to do, if you want to really see this one, we need to JSON dot, we need to I copy this one again, the repository JSON dot stringify. I had to spell the stringify, sorry for that, and let's deploy. Let's delete all the logs, we don't need this logs, and try to go back to our Postman, and let's send a message. The message got sent. Okay, we will do the again, and let's go back to our logs, see how does it look like the response object. So this is response object. Okay, here we go. Now we do have a little bit more details. As you can see, we are looking for the items and the connection ID. So we are sending the connection ID. Once you send the connection ID, all the connection over here. So user is a connection object. On particular object, we do have a something property called S. That is where actual data is. So that's why we are using the user.s. So sometimes you may realize some issue with when you extract in the data. So that's why we need to use kind of console logs and see the actual response come from dynamodb table, because in your case the table is different. It could be the int, it could be the some GUID, it could be. So therefore just put the console log and do the troubleshooting if you get any error. Finally, WebSocket API support authorizes WebSocket usage plan API and many more as Web API support. So if you are interested with those topics, please check the description below. Right, that is pretty much about the Web API for today. Hope you enjoyed the video. Again, please like and subscribe if you like this video and really appreciate it. So see you on next video. Thanks.